Alright, so I went and made something, and I got so excited in starting the project off that I didn't really do a good job of explaining what I did. But here, let me show you the finished product. Oval, round. Pretty neat, huh? So, the part is supposed to be 22.72 across the flats. So that's pretty good right there. And then across the length, it's supposed to be 33.75. So heck yeah, dude. Alright, how did I make that? 3D printed press tooling. And I squeezed it together with the bench vise, not even a real press. So here's my process. I first made this guy. Well, back it up. I went to town and bought 1-inch copper couplers, and then I foolishly assumed that a 1-inch copper coupler would be 1 inch in diameter, but they're not. They're like 1 1/8. So that was really dumb of me not to actually measure the thing I bought. Anyway, I printed this first test die and made it for a 1-inch part. So that was silly of me. Anyway, so this guy goes from a 1-inch round to the correct oval size. So basically I did a reverse of the math for the equivalent diameter of a round for what it flows through a flat-sided duct. I'll link a picture of the formula for that. So I just kind of picked the A and B width, and then I adjusted the numbers to meet that 1-inch equivalent diameter. So that was the first idea. So then I had to bump this up to 1 1/8, so I had to bump that up too. That was relatively easy, not too difficult there. But so I put this guy on, and you can see it wasn't a uniform press. It was kind of scraping in there. But this kind of gave me hope. So I took a hammer and kind of flatted the sides, and I made a tiny bit of an oval, not that much. So this was a good start. And this was straight from the store. Didn't do anything to it. This guy, per recommendation from a metalworking friend of mine, he told me get this guy red hot and throw in a bucket of water. And copper is different than steel in that when you quench it like that, it actually gets softer and not harder. So made this thing nice and soft. I can't necessarily like squeeze this and bend it, but it is softer. So this is the plastic part post-use. So seeing as if I pressed something onto this guy, this is narrower, this is wider, this is wider, this is narrower. There's no way to take a copper part off of this once you press it on unless you go backwards and then it goes back to round. So that's not going to work. So you could just burn the thing and melt this out, which might be an option, depending, we'll see. Or you could do like what I did here, and I made a multi-piece assembly. Now I'll need to make some modifications for the next one when I go bigger. But before we talk about how this works, let me show, let's see, where we're at. So we're at a 22.9. when it should be a 22.72, almost a 23. So the imperfection in the size of this part may very well could be the imperfection in the 3D printed plastic part. You know, my printer's not perfect. And then this is a 3380-ish, depending on where you put the calipers on. Sometimes a little lower, sometimes a little more. But end to end, it's supposed to be 3375, and this is a 3384. So we're making dimensional parts based on the piece of plastic. So that's like really exciting to me. you know, just a little bit off, but that's within a workable range. 3386. I mean, look at that. That's awesome. Okay, so let's break this guy apart and show you what I did. I didn't break it apart later on in the video, which happened earlier in the day. So let's pull this guy apart. So this is a retaining ring, and it's tight, which is a good thing for what this guy has to do. There we go. All right, it's just that easy. Okay, so the idea was you have a multi-part assembly here, and see how these guys are threaded. Yeah, the idea was you have a threaded rod going down the middle. You take the threaded rod out. This guy is small enough to slide and pop out, and then the idea is now these two can collapse and slide down and out. Now, unfortunately, that just isn't possible when you have both of them in here. There's just no way to get them both out. So in my video, I ended up pounding them both out at the same time. And when I did that, here you can even see here. Yeah, that's just it's not going to go in either way. So, you know, it's a learning experience. These are test parts. These are not finalized parts, right? So when I pounded it out, it oblonged this hole. So you'll see later in the video, I assembled this backwards, and that's why that retaining ring was down here. Because this has about a 1/4 inch of flat space back here where it's the correct oval diameter. So I sent it beyond, and I repressed this guy back in, and that re-ovaled it and made it a great shape. So like I said, the goal was to have a self-disassemblable piece here. So the key to that is having this less than 45-degree angle. So right, if you have an XY coordinate, greater than 45. So this guy is like a 50 something degree, 55. This one's about a 50. The idea is that these guys actually want to push it out. So that's why that rod's important. That's why the retaining ring is important. So for version 2, it's become clear to me that we need another one over here. So this will be a 4-piece apart with this guy. So 5 pieces, and then that guy 6 pieces. So, but I have a feeling it's going to work great based on everything I've seen. When that copper is soft and annealed, it is easy to work with. Right, so there's that. So I didn't undersize the shaft for this hole, so that was foolish of me. And yeah, this guy was tight. I had to sand a radius onto the corners, and because of print orientation, I don't know if I'll be able to print in a default radius to help the ring slide on. I could do a radius at the top to help that guy slide on. Where's the thread then? Okay, so this guy was taller, and I ended up subtracting length from it, and then I forgot to subtract it from the threaded rod. Actually, the threaded rod should be pointing this direction. So let me, oh, not even on camera. My bad. So threaded rod was too long. I forgot to shorten the threaded end. I gave it a 1/4 inch driver, so the little 1/4 inch socket driver could drive this in. But this guy just had too much resistance in here because it was too large. Well, it wasn't exact, so foolish me, didn't include any clearance. Too much resistance, so I ended up cutting this guy off and just hammering this guy in. And then hammering it out. So there you have it. Version 1 of the multi-piece benchtop vise pressed copper manifold test piece. So this being a 1 1/8, this is nowhere near what we need for the H6, the EZ30. I need a 1 5/8 inner diameter on a copper tube. So we might not use copper. There's some ultra formable brass, might use that. We're just gonna have to see. So anyway, let's get into the video where I make this thing. Hope you enjoy it. Alright, so we've got version 2 of a mandrel, or a press die, and we've got a freshly annealed piece of copper. Now, the idea behind this guy is that, hang on, let's focus it, there we go. We have a 3-piece die with a plug. When the plug gets removed, the idea is that you can slide that guy out, that one, the little guy. So we'll see if it works. I discovered that if you have a solid piece and you press this guy on, there is no getting it off, because this is narrower than up there. So yeah, we'll see if this works. This is a removable retaining ring to keep it all locked in. I initially had the goal of having a threaded end that would thread in. Made the rod size of the plug too large, didn't allow enough clearance, so I don't know, we're just gonna have to see if this works. I had to cut off the end, so let's just see. Alright, let's see, what are we seeing? There we go. Alright, we got the tooling just about ready to go. Let's see what it'll do. That looks fairly level. Square. And she's going. We're getting a minimal amount of peeling right there. I can see it flaring out, that's for sure, and it's staying flush. It's not peeling up. Wow, this is so far looking very good. Yeah, it's definitely peeling a little bit, but that's really not that much. That was just that one little guy. I don't see any peeling anywhere else. It's definitely requiring some pressure. Holy Toledo. That worked out really good. Who knows what the spring back's going to be, but let's take a look here. It's definitely wider on the left end over there. Definitely narrower there. It was sucked tight to that flat of that plastic. Alright, set this back up. Let's see about pulling this apart. Wow. Look at that. That's cool. So yeah, the goal, get the plug out. And then this guy should, with the angle of that cut, it should slide to the middle and drop out the center. So let's do the retaining ring first. Alright, there's that. You know what? Since we pulled that, let's sink it a little deeper. That will also give a larger surface of the material that's at the correct flat dimension, if that makes sense. I don't have this vise locked in yet. I don't know if I'm going to be able to make her go any tighter. Let's try the other angle. And that's it. Until I lock this vise down. Oh. Well, that's why it was so hard. No. Alright, let's wind this in. How are we going to do that? We probably need to go something like that so we can tap it out. So I need to go get a punch. Be right back. All right, we're going to try a long socket just to see if we can get it started. It's going. Need a longer long socket. Yeah, I can grab that. Yeah, so like I said, my original goal was threaded. So the parts in here are threaded. I just couldn't get it to go. It was too tight. So we'll fix that up if this is successful and we want to try this again. Oh boy. Let's try twisting. Ah, that's right. Can't shear this stuff. Alright, I'll go get longer punches. Be back. Alright, I just grabbed what I had laying around. Just a big old lag bolt. Since this was already broken. Well, who cares? Okay. Now the goal is to get this little guy out. So if this ends up being a 100% sacrificial build, I'm just going to burn these out. I mean, the plastic will burn away, but it'll be a mess. But if it's sacrificial anyway, then there's no reason screwing with this thing. So let's see what we can do to get this guy out. Maybe the chisel, huh? What do you think? See if I can get my fingers. Oh, that wasn't too bad. That was barely anything. I put a teensy tiny little nick in it, but dang, that wasn't bad. Alright, now the real test. Yeah, I don't think so. Clearly, it needs to be a 4-piece. It needs to have another chunk over there. Alright, let's do some similar tapping. See if I can get it to come free. Oh, there's that. Oh, yeah, don't get too excited yet. Oh, it's so close. Oh man, look at that. So close. Let's see, I wonder if I can't go vertical, that's for sure. I'm doing two at once. Is that gonna work? Oh man. Nope. Let's try that. Let's open this up. We'll see if I can get it to grab just the copper edge gently. I mean, they're coming, it's just taking its time, little by little. I'm messing up the bottom of the copper, especially after annealing it. Oh man, but look at that. I think I oblonged this guy when I was pushing these out. But hey, proof of concept. Oh man, that's such a bummer. I wish it didn't oblong. Let's look at these. Let's see, there's the two tops. Yeah, it's a little beat up. Just a tiny bit beat up, not bad. Let me pause this. I'll see if I can get this retaining ring. I want to see if I can use this as a measurement tool just to see how it lines up. So hang on. Alright, I got the measurement tool assembled. I had to stretch this guy down over the bottom there. Let's take a look. Yeah, it's definitely, I don't know if you can see them when they're side by side. Let's try that. This guy got oblonged over there. probably even just press this back over the end. Let's try that. That would probably straighten it out a little bit. Alright, come on. Oh, I really need to tie this guy down. This is a new extension to the workbench, and I need to re-drill. Okay, it's sheared off a little bit over there. Okay, let's see what that did. Ooh, that helped. Wow. I can't believe how well that worked. Slips right over it. Alright, let's call it here. One more little addendum. I stuck this back on and I hammered it just a little bit. You see how I kind of bowed it just a little bit? Anyway, that looks really good. Look at that. Just slides right in. That was not any force. So, I'll go back to the house. I'll measure this thing. I don't even remember what these dimensions were exactly, so we'll go measure it just to see how close we were. But so far, I think this is a go. Pretty sweet.